Yes, a waterproof connector exists for Romex and is commonly referred to as a Romex Weatherproof connector or a Romex Weatherhead connector. These connectors are designed specifically to create a seal where Romex cable enters a weatherproof box, preventing moisture from reaching the electrical connections. Typically, it is a small plastic box that incorporates a rubber gasket designed to tightly seal around the Romex cable when properly installed. The connector also features a threaded fitting that allows it to be securely screwed into the weatherproof box. When using a Romex weatherproof connector, you'll firstly need to prepare the Romex cable by carefully stripping away the outer jacket. This exposes the individual insulated conductors within the cable. Secondly, gently twist these individual conductors together to ensure a secure and reliable electrical connection. Thirdly, insert the prepared conductors into the designated openings within the Romex weatherproof connector. Fourthly, carefully tighten the screws or clamping mechanism on the connector. This action secures the conductors firmly in place, creating a robust and lasting electrical connection. Fifthly, proceed to screw the Romex weatherproof connector securely into the threaded opening of the weatherproof box. This step creates a watertight seal, preventing moisture from entering the enclosure and potentially damaging the electrical components. Romex weatherproof connectors can be found at most hardware stores and electrical supply retailers. They are a cost-effective solution for protecting Romex cable in outdoor or damp locations. When installing floodlights under an overhang, there are several important considerations to keep in mind. Firstly, the overhang should be of sufficient size to adequately shield the floodlights from rain and snow. This will help to prolong the lifespan of the fixtures and reduce the risk of electrical hazards. Secondly, choose floodlights that are specifically rated for outdoor use. These fixtures are designed to withstand the elements and are constructed with materials that resist corrosion and water damage. Thirdly, ensure that the floodlights are securely mounted to the overhang. Use appropriate mounting hardware and techniques to prevent the fixtures from becoming loose or falling down. Fourthly, always use weatherproof connectors for all electrical connections associated with the floodlights. This will help to prevent moisture from entering the wiring and causing short circuits or other electrical problems. Fifthly, once the installation is complete, thoroughly test the floodlights to verify that they are functioning correctly. Check that the lights turn on and off as expected and that there are no signs of electrical issues. Regarding the choice between Romex and underground feeder or off cable, Romex is suitable for dry, interior locations. UF cable is designed for direct burial in the ground and is more resistant to moisture and physical damage. Since the Romex will be located behind the box and under an overhang, it should be protected from direct sunlight and rain. However, using a weatherproof connector is still crucial to prevent moisture from wicking into the box. In residential wiring, it is common to use Romex for interior circuits, while in commercial settings, conduit systems like electrical metallic tubing, or IMT, or rigid conduit are often preferred for their durability and protection against physical damage. Always consult local electrical codes and regulations to ensure compliance with safety standards. Here are a few important points about working with electrical systems. Firstly, always turn off the power at the circuit breaker before working on any electrical wiring. This is crucial for preventing electric shock. Secondly, use properly insulated tools designed for electrical work. This will help to protect you from accidental contact with live wires. Thirdly, never overload electrical circuits. Overloading can cause overheating and potentially lead to a fire. Fourthly, if you're not comfortable working with electricity, hire a qualified electrician. Electrical work can be dangerous and it's best to leave it to the professionals if you're unsure of what you are doing. Here's some information on National Electrical Code, or NEC, requirements for outdoor lighting and wiring. The NEC provides specific guidelines for the installation of electrical equipment in wet or damp locations. These guidelines are designed to ensure the safety of people and property. For example, NEC Article 410 covers the requirements for luminaires, lamp holders, and lamps. It specifies the types of fixtures that are suitable for wet or damp locations and how they should be installed. NEC Article 314 covers the requirements for junction boxes, outlet boxes, and pull boxes. It specifies the types of boxes that are suitable for wet or damp locations and how they should be installed to prevent moisture from entering. NEC Article 334 covers the requirements for non-metallic sheet cable, which includes Romex. It specifies the conditions under which Romex can be used in wet or damp locations and the types of fittings that are required to protect the cable from moisture. NEC Article 340 covers the requirements for underground feeder and branch circuit cable, or UF cable. It specifies the conditions under which UF cable can be used for direct burial and the required burial depth. When installing outdoor lighting, it's important to select fixtures and wiring methods that are appropriate for the environment. Fixtures that are listed for wet locations should be used in areas that are directly exposed to rain or snow. Fixtures that are listed for damp locations can be used in areas that are protected from direct exposure to rain or snow, such as under an overhang. Wiring methods should also be selected based on the environment. UF cable is typically used for underground wiring, while Romex can be used for above-ground wiring in protected locations. It's also important to use weatherproof fittings and connectors to prevent moisture from entering the electrical system. These fittings and connectors are designed to create a watertight seal around the wires and cables, preventing water from seeping in and causing corrosion or electrical problems. Always consult the latest edition of the NEC and local electrical codes with specific requirements and guidelines. The NEC is updated regularly to reflect changes in technology and best practices, so it's important to stay current with the latest regulations. Also be aware that local codes may be more stringent than the NEC in some areas. Here's more information about grounding and bonding. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. Bonding connects all metal parts of the electrical system together to create a low impedance path for fault current. This helps to minimize the risk of electric shock and fire. The NEC provides specific requirements for grounding and bonding in Articles 250 and 250.100 and beyond. These articles cover topics such as grounding electrode systems, equipment grounding conductors, and bonding jumpers. When installing outdoor lighting, it's important to ensure that all metal parts of the fixtures and wiring system are properly grounded and bonded. This includes the metal housings of the floodlights, the metal junction boxes, and any metal conduit or enclosures. Grounding electrodes should be installed in accordance with the NEC and local codes. Common types of grounding electrodes include ground rods, ground plates, and metal water pipes. Equipment grounding conductors should be run with all circuit conductors to provide a low impedance path for fault current. Bonding jumpers should be used to connect all metal parts of the electrical system together. It's also important to properly label all grounding and bonding connections. This will help to ensure that the system is properly maintained and that any future modifications are made correctly. Here's some additional information about circuit breakers. Circuit breakers are designed to protect electrical circuits from overloads and short circuits. When a circuit breaker trips, it interrupts the flow of electricity to the circuit, preventing damage to equipment and reducing the risk of fire. Circuit breakers are rated in amps, which indicates the amount of current that they can safely carry. It's important to select circuit breakers that are properly sized for the circuits they protect. Overloading a circuit breaker can cause it to trip frequently, which can be a nuisance. It can also damage the circuit breaker and potentially create a fire hazard. Short circuits are caused by a direct connection between two wires that are at different voltages. Short circuits can cause a large amount of current to flow through the circuit, which can quickly damage equipment and create a fire hazard. Circuit breakers are designed to trip quickly in the event of a short circuit, preventing serious damage. The NEC provides specific requirements for the installation of circuit breakers in Article 240. This article covers topics such as circuit breaker ratings, overcurrent protection, and short circuit protection. When installing outdoor lighting, it's important to ensure that the circuits are properly protected by circuit breakers. The circuit breakers should be sized appropriately for the load and should be installed in accordance with the NEC and local codes. It's also important to periodically test circuit breakers to ensure that they are functioning properly. Circuit breakers can fail over time, so it's important to replace them if they become unreliable. Some electrical codes call for specific types of breakers, such as ground fault circuit interrupter or GFCI breakers in wet locations. Here is some important information regarding wire sizes and ampacity. Wire size refers to the physical diameter of an electrical conductor, typically measured in American wire gauge or AUG. Ampacity is the maximum amount of electrical current, measured in amps, that a conductor can safely carry without exceeding its temperature rating. The NEC specifies the ampacity of various wire sizes in Table 310.15, formerly Table 310.16. This table takes into account factors such as the type of insulation, the ambient temperature, and the number of conductors in a raceway or cable. When selecting wire sizes for electrical circuits, it's important to choose conductors with sufficient ampacity to handle the expected load. Undersized wires can overheat, which can damage the insulation and create a fire hazard. The NEC provides guidelines for calculating the minimum wire size required for various types of circuits. These guidelines take into account factors such as the load current, the voltage drop, and the ambient temperature. Voltage drop refers to the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause appliances and equipment to malfunction. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. When running Romex cable outdoors, even under an overhang, it's recommended to use a weatherproof connector to protect the wires from moisture. Here is some clarification on waterproof versus weatherproof. The terms waterproof and weatherproof are often used interchangeably, but they have slightly different meanings in the context of electrical enclosures and equipment. Waterproof means that the enclosure is completely impervious to water, even when submerged. Weatherproof means that the enclosure is designed to protect against rain, snow, and other weather conditions, but it may not be completely waterproof. For most outdoor lighting applications, weatherproof enclosures are sufficient. However, in areas that are subject to flooding or prolonged exposure to water, waterproof enclosures may be necessary. The NEC provides guidelines for selecting enclosures for wet and damp locations in Article 314. This article specifies the types of enclosures that are suitable for various environments. When selecting enclosures for outdoor lighting, it's important to choose enclosures that are listed for wet or damp locations depending on the environment. It's also important to ensure that the enclosures are properly sealed to prevent moisture from entering. Here are some additional safety tips for working with electricity. Firstly, never work on electrical equipment while standing in water or on a wet surface. Water is an excellent conductor of electricity and can increase the risk of electric shock. Secondly, always use a ladder that is made of non-conductive material, such as fiberglass, when working on overhead electrical equipment. Metal ladders can conduct electricity and pose a serious hazard. Thirdly, never touch electrical wires or equipment with bare hands. Always use insulated tools and gloves to protect yourself from electric shock. Fourthly, if you smell burning plastic or see smoke coming from electrical equipment, immediately turn off the power at the circuit breaker and call a qualified electrician. Burning plastic or smoke can indicate a serious electrical problem that could lead to a fire. Fifthly, be aware of overhead power lines when working outdoors. Maintain a safe distance from power lines to avoid accidental contact. Contact with overhead power lines can be fatal. It's also important to have a fire extinguisher nearby when working with electricity. In case of an electrical fire, use a Class C fire extinguisher, which is designed for electrical fires. Never use water to extinguish an electrical fire, as water can conduct electricity and make the situation worse. Remember that electrical work can be dangerous, so it's important to take all necessary precautions to protect yourself and others. If you're not comfortable working with electricity, hire a qualified electrician to do the work for you.